everyone. Before I start, I want to ask, who here is using AI? That's bad. Who here has studied or is an expert in AI or machine learning? OK, that's better. I want to see how many well-actuallys I'm going to get. I hope there are not many. Jeff will back me up if I hear too many. Well, actually, this is not accurate. So yeah, just a disclaimer before we start. OK, so today we're going to talk about how you can enhance your doc's UX with AI. And yeah, let's dive into it. We're going to start with a short presentation first, and then dive into the actual part. I'm Katerina. I'm a senior engineer at NX. I'm also a Google developer expert for Angular and Google Maps. I'm also a Women Tech Makers ambassador, a speaker, an instructor, and I like cats, mountains, oatmeal, and chocolate. And you can follow me at Cyber City. Also, I have lots of stickers to give you during the workshop. So today, also I have lots of pictures of my cats in the slides, because you know how parents sometimes bore you with pictures of their children that you don't want to see? That's me with my cats. I always show pictures of my cats to people that they don't want to see. So here you're forced to see pictures of my cats. So thank you for laughing, breaking the ice a bit, making sure everyone is paying attention. OK? So core concepts we're going to see today. What is an AI? What is considered an AI assistant? An explanation of what embeddings are, which may not be 100% accurate and scientific. What generative AI is, we'll talk about context and prompting, and why you would want to use AI for your docs. And then we'll see how you can build your own. So let's dive into the core concepts. So what is an AI assistant? As you may have noticed, an AI assistant these days, what we call an AI assistant, is like a chatbot, basically, that has context of your documentation or of a knowledge base that you want, and drawing from that knowledge base gives you answers. Some notable examples are Houston from the Astro team, Clippy from Supabase. You have the ng-conf AI help, which I haven't used, but it's there. The Warp AI and the AI command search of Warp. Who uses Warp here? We got one person, and he's my colleague. Good. We have the NX AI assistant, which is our AI assistant, and the Angular one, which is coming soon, apparently, as we heard today during the keynote, right? This is where you say yes, and they make sure you pay attention. Thank you, Jeff. Let's take a look at this short presentation I gave to my colleagues a few months ago of what embeddings are. Super short, and probably not 100% accurate. By accurate, I mean scientific explanation of embeddings. Thank you for smiling. So embeddings simplify. So think of embeddings like sorting toys. Each toy, or word in this case, is placed in the room, the embedding space, based on its features. A red car might be near a red truck and far from a blue doll. Similarly, the word happy may be near to joyful and far from sad in the embedding space. Let's take a look at these graphs that may represent this in a more graphical way. So think of words as vectors. Vectors are essentially arrays of numbers, right? So if you have a two-dimensional vector describes a line. So you could map these, the words as vectors, on a two-dimensional map. This is a very simplified representation of it. So in this map, if you had like an axis of age and an axis of gender, you would see that grandfather would be on the top left, girl would be on the top right, for example. In the three-dimensional graph in the next image, you can see that if you had like wings, sky, and engine as the three axes, you would have helicopter on like one side on the high up and B on the other side. So think of this as exactly taking the word B, giving it like the machine figures out how to give it some number, assign it some numbers, and then you map these numbers into not space necessarily, but whatever the computer understands as the representation of a multidimensional array. So embeddings are a type of word representation that allows words with similar meaning to have a similar representation, as I explained. They convert words into multidimensional vectors, arrays of numbers, giving machines a way to understand words in relational terms. Why use embeddings? Well, machines understand numbers. Traditional language models often struggle with understanding context and relationships between words. By giving them arrays of numbers, vectors, or embeddings, we allow the machines to understand semantic and syntactic similarity, relation with other words, and much more, as we saw in the graph before. Embeddings work by taking a large corpus of text and representing each unique word as a vector in a high-dimensional space. And similar words are close to each other, allowing machines to understand this relationship. Pre-trained models like GPT, which we are going to use today underneath for our AI assistant, already come with learned embeddings from a vast amount of text data. So GPT has been trained in a vast amount of data. It has created embeddings out of this, and this is what it uses to do whatever it does. When dealing with specific documentation, however, unique context, we can create new embeddings from our documentation, and we can pass this as context every time we ask the AI something. This allows the model to make more accurate predictions and analysis based on our context and our documentation. So creating new embeddings for specific documentation provides a personalized guide to the pre-trained models like GPT to better understand our specific use case. And we're going to see how we're going to do that. What's an embedding vector? We explained what it is, but let's see it again. An embedding vector, as I said, is a unique representation or list of clues that represents a word in a way a computer can understand. The screenshot here you may not be seeing it very clearly. We're going to see it further down during the workshop. Is a screenshot from Supabase. So Supabase is like an online database thing. And this is a table that contains embeddings. On the one column, it has the actual text, and on the other column, it has the actual array of numbers that represents that text. And so you have a table and a database that you store the embeddings to. Each word is described based on many factors. So for example, the word grandfather that we saw before can be described by many words according to whatever makes sense to the computer or the model that does it. The purpose is to help computers make sense of the words. And an example is like describing a toy car as red, small, and car shape. This combination of description or clues is similar to how an embedding represents a word, but it represents it in an array of numbers. With these embeddings as vectors, a computer can guess what the word is and how it's used, even without seeing it in a sentence. And because it's a vector, because it's an array of numbers, because it is what it is, the computer, the machine, the algorithm can then predict the next word, which is how GPT works eventually. What is generative AI? It's a subset of AI, of course. It's the technology driving these assistants, and particularly the NX AI assistant is the technology behind GPT. It's not just to classify input data, but it generates new content. In this case, it's going to be taking in textual prompts and outputting coherent text, but generative AI can take as input images, videos, or what have you, and generate the exact same thing. I mean, if you've used Midjourney or DALL-E, which I'm sure all of you have used, this just generates image or audio or video from text or vice versa. What does generation mean in its sense? In AI, especially in natural language processing models, generation refers to the process of producing sequences of data, in our case text. It's about creating content that wasn't explicitly in the training data, but follows the same patterns and structures. And as I said, because it's numbers, the computer can sort of predict the next number, but not like that. Where is the term derived from? It's text that mimics training patterns. It's just generation. How does GPT work? GPT stands for Generative Pre-trained Transformer. It uses a predictive mechanism. It's pre-trained to predict the next word in a sentence. So when you provide GPT with a prompt, it uses that as a starting point and keeps predicting the next word until it completes a response or reaches a set limit. We're going to see the limit, to setting the limit as well. So in essence, what GPT does is GPT reads your prompt, which means it takes in the embedding of your prompt. It thinks using training data, so using that embedding that you gave it, it starts outputting the most likely next word, and it repeats until it has a coherent response. What is the context? In the context of AI, the context is the surrounding information, data, or conditions that provide a framework or background for understanding and interpreting a specific input, ensuring that the AI's responses or actions are relevant, coherent, and meaningful in a given situation. So the context that you may give your assistant, or the context that you added to GPT is that, for example, I have added the context that I'm a woman, I'm 36 years old, I am a software engineer, so it knows how to respond, right? The prompt is the initial seed that guides the AI's output. And by refining the prompt, users can better direct the AI's response, ensuring the output matches their intent. I'm pretty sure that we're all, after 1.5 years of using GPT daily, I think we're all trained to create good prompts. So we all know what a prompt is. So here is the million-dollar question. Why even use AI for docs, right? Because I'm pretty sure if you have a tool or if you're using a tool, you go to their docs page, you go on the search bar, you find what you need, or you go like to their contents and you just find what you need. Why even bother adding AI to the docs? So let's face it, let's tell it as it is. There are and if you're building a tool and you have to write docs, or if you're going through docs, there are some challenges that follow documentation, either writing documentation or retrieving documentation. First is the volume and density of documentation, right? A tool can have like huge documentation that is not easily discoverable. The search may be tricky because you usually try to start a keyword match with sources like Algolia. Even if you do fuzzy search, you're still looking for keywords, right? Also, you may have the need for personalized and contextual search. So you would have to click to find something here, and then find something there and combine it. And even some search engines may not be super able to understand what, for example, you want to search for something, but you don't know the exact keyword. You cannot really describe what you want, and Algolia would give it back to you, right? So this is where the generative AI will come in, and the AI assistant would come in, because it goes beyond simple queries. For example, you can go on the Angular website, or I don't know what, and describe what you want with your own words, and because the description, so for example, if you're looking for schematics or I don't know what, you could describe what you think schematics are, and because the description of schematics would match what you're looking for, it would give you back the right page without even you writing the word schematics. Also, what's great about AI assistants is usually they use a chat interface, so you can ask a question, then you can ask a follow-up question, and you can chat as you chat with GPT, right? So it's good that you can go back and forth and actually get the result that you really need from the documentation. And so you can also, in this way, mix and combine docs. So maybe you want something about schematics, but you also want something about signals. So it would fetch something from a page here and fetch something from a page there and combine the two and give you back a full answer with the sources, of course, of where it found the answer. And this is why we think that this is enhanced user experience, right? Because it enhances and it expands documentation retrieval. And it enhances discoverability of your documentation. Potential benefits for the authors being those who write the tools and the docs. Of course, you can keep track of what the users are asking, and then you can identify what users are looking for, what questions need to be answered. So maybe you can adjust your docs and create new docs pages. Also, you can identify potential unclear parts of your documentation if AI consistently gives bad answers, or if users keep looking for the same things but they cannot find them. And as I said, more parts of the documentation may be more accessible through the links and the sources that an AI assistant would provide. Of course, all of these are based and rely on the users providing feedback. So if you build your AI assistant for your docs page, make sure you add a feedback mechanism that the users can use. So how to build your own? A basic overview is you take your docs, and you split, if they're in Markdown or if they're in whatever, you split the docs down into sections, like, for example, per paragraph. Then you create embeddings for each section. Then you store the embeddings you create in a database. And the reason we create the embeddings is because we want them to be searchable and retrievable. Then the user asks a question. You create an embedding for this question. And what you do is you query your database to find sections similar to the question vector. So you have a vector for the question that was asked. You have all the vectors stored in your database. You do vector matching. You use Postgres, like the PG vector, for example, library, to fetch back similar results from your documentation. Then you bring back the sections that match the embedding. Oops, what did I do? And you use that, you put all the sections together, and you use this text as a context for the final query that you're going to finally ask your assistant. So you have back the sections, like the section that you want to use. You say, use this text here to reply to the question of the user, and then add the question of the user. You send the full query to GPT in our case, and you get back the answer from GPT. So it's simple as that, the steps. So let's see how you can build your own. The implementation was based on the Supabase Docs Assistant, but we sort of enhanced it for NX, and we're going to see this here, how you can build it with Angular, and how you can use it on the Angular docs or on whatever docs you have. And you can try out the NX AI assistant as well. Now let's get coding. I will give you a few moments. Who here is going to actually code? OK, pretty few people. OK, so you can go to this page here on GitHub. Jeff, you're actually going to code? Thank you. Thank you. Sorry. No, I'm honored. Is anyone who doesn't have the link and wants to have the link? Give it 15 more seconds. OK, 50 seconds are up. Wait, I want to clone my screen now. Mirror display. OK. So let's go and let's get started. So if you go to this here, to the doc starter, the tools that we're going to be using today is the OpenAI API to create our embeddings and get back our chat completions. We're going to be using Supabase to store our vectors, and we're going to be using an X, because an X is amazing. Who here is using an X in general? OK, that's nice. So as I say, most code is adjusted from the NX assistant, which you can find the links here. And what you need, unfortunately, if you really want to complete your assistant, you will need some API keys. If you just want to follow along, you may not have the keys. It's OK, but it won't work for you. But if you take it home, if you add the keys, it's going to work for you. This repository here that we have is the starter repository. There is also the finished version of it. It's just exactly the same as just the finished version, which you will be able to find here, and you can clone and use for your own thing. And I have some useful links here. So let's go to the tutorial page to get started. First of all, you can clone this repository and install the dependencies. And so in order to get API keys, especially for OpenAI, you will need a card that you can. I don't think it's going to charge you much, but I'm just saying. So who here is going to add API keys? OK. So I'll give you a minute. I have explanation here of how you can get your API keys from Supabase and from OpenAI. And once you get your API keys, you can go, wait. You can, look how fun these people are having. Do you want to make some noise? Yeah. Come on. Woo! OK. That felt good. You can go to this file, remove the .sample, and add your API keys in there. And it's git ignored, so it won't be checked into your repository. So yeah, I'll give you a minute here if you want to get API keys. And then we'll go to the next step. I'm literally giving you a minute. I'm looking at the time. Look at these people showing off. OK, minute is up. So let's say now you have your API keys. And who here has Supabase set up? Because you still have to at least have a Supabase setup. Nobody. OK. In any case, luckily, the tutorial is very detailed with screenshots. So if you go home and you want to do it, you will be able to do it from here. So in your project dashboard, if you go to the left side and click the SQL editor, the great thing is that Supabase offers a, where is it? It's in quick starts, right? Supabase, in its quick starts, it has some templates that you can use in there. Who here has ever used Supabase? OK. I haven't used it much either, but just I've only used it for this. I think it's great. I think it's very handy. In any case, it has a lot of quick starts that you can use to just create your own things. They actually have an OpenAI vector search starter that you can use, and if you click that, what it will do is it will just create the tables that you need in your database, which will be two tables, one called nodes page and the other called nodes page sections. In the sections, it's going to store the embeddings for each of the documentation sections that you're going to use. And it's also going to create a function here that we're going to see exactly how it works, which calls the PG vector search function that will actually look up based on your queries embeddings. It will find the relevant embeddings from your documentation sections. But this is all ready-made. You don't have to write anything. So this is very nice of Supabase. And then if you go into your table editor and look at your two tables, you will see all your page sections. They will be empty for you. For me, they are already filled in because I have run this. They will be filled with text and embeddings, which, as I showed, let me make this a bit bigger. No? OK. Which, as I showed, you can see the embedding here is just this array of numbers. Good. I'm going to give 1 minute for this to, if anyone wants to do it. Maybe not, but yeah. Oh. OK, I'll give you a minute, yeah. Yep. The privacy? You can host it locally too. This is online. I'm not sure. I've only used it for our documentation, which is open source, and Angular's documentation, which is open source as well. I'm not sure of their compliances and anything. But yeah. That's a good question, though. Yeah. No, don't leave, please. OK, people are leaving. We need to step this up. You need more cat pictures? I'll show you later. OK. So now, let's first understand the embeddings code, because this is sort of the important part of your assistant, because the most important thing is that you actually create the embeddings for your documentation. You can find the embeddings code. We're going to go through the embeddings code. This is not a part where you will write anything, because I don't want to say it's complicated, because maybe it's not complicated for you. For me, it was a bit complicated. So the embeddings code, what it does is it splits down its Markdown file into sections based on Markdown headings. Then it creates an embedding for each section using the text embedding ADA model from OpenAI. You can choose different models for embeddings for whatever you think works best for you. We're just using this model here. And then it saves the section embedding on Supabase. Detailed breakdown of the code is that, let's actually open the code. A detailed breakdown of the code, let's take a look. First, we have this function that splits the Markdown tree into sections, as we said. And I think it uses it uses the from Markdown from this library here, the mdast from Markdown. So it's using a tool that is made for that, to break down things into sections. And what it also does, it creates a checksum from each content page, so that if you want to regenerate if you want to regenerate embeddings for your documentation, it just checks the checksum if it's the same so that it doesn't do double work. So if the checksum is the same, it just skips that page and not generate documentation. It also adds the slugger to the page. And like if it has a heading, it uses that heading as the slug. These are just for retrieval later. Now let's go down to the... So what you do here is it takes its file, it reads the file, then it processes it for Markdown, it has the checksum, it has the sections, and eventually it goes into the generate embeddings function. Let's go to... OK, first it creates a client on Supabase. Then it reads the file path, of course, and let's see. And here is where the magic happens. No, first here it checks if the checksum is the same. If it's not the same, it will add the page section. And where is it when I'm generating the embedding? Sorry. Here. OK. So what it does for each page is it calls the OpenAI.embeddings.create function. And in that function, it chooses the model, which, as I said, can be text embedding 8.2, text embedding 3 small, text embedding 3 large. And it adds the input. The input is just the content of each of these sections, right? And then it goes and it adds this input with the embedding, the token count, and the heading and the slug into the nodes page section array that we created before with the SQL query that we ran. The reason we are adding the token count as well is because maybe you want to add some restrictions to how large the prompt that you're given you want to be, or how large the response. So it's really important if you are cost savvy to know how many tokens you're passing back and forth, which I guess makes sense. So this is pretty much what this function does, the generate embeddings function. I have a detailed explanation here. If you go home and you want to build on your own, you can read the detailed explanation here. But basically, by the end of this process, we have a system that can read through our Angular documentation, in this case, break it down into manageable sections, generate meaningful embeddings for each section, and store these embeddings for quick retrieval. So if I were to go here in my application and run, let's actually see it running. AI. If I run, what do I run for embeddings, though? To generate embeddings. If I run nx-run embeddings create, it would go ahead and start creating embeddings for each of these pages, right? So it would take each of this page and say, add in one page section to Supabase, then second page section. It found 300 pages. It's going to do that for 300. We're not going to do this now, but this is what's going to look like. And once it processes all the pages and it saves all the pages to Supabase, it will stop. And if you go to your Supabase and you look into the node space section table, you're going to actually see the sections here with the content and the vector array. Any questions so far? Yes? Pretty much, I think this was like the default one. But the difference in the models, I think, mostly are the costs. And I think it depends also in how large the text that you want to create an embedding for is. So I think it's trial and error. This is my most scientific response. If anyone knows better, you can speak up. Oh. Yeah, it's pretty expensive, GPT-4. But this is for the completions. For the embeddings, I'm not sure. But yeah, the completions and which model you use for the completions is another story, because yeah, GPT-4 takes more input, you can give more inputs, you can get better outputs, but it costs way more. So if you're not super worried about getting like the super analytic detailed things, you can still go with 3.5 and still be okay. I think that's what we're doing in the NX assistant, because it works pretty well with 3.5 too. But you can, of course, when you get to the prediction model, you can still do A/B testing with your users and see which one works better. That was a very good find. Yeah. Yeah, definitely. So now we come to the part, so we generated our embeddings, we have our database ready. Now how do we communicate with OpenAI when a user asks a prompt? In this section, what I've done here is I've set up a Nest.js application, because Nest works very well with Angular, that interacts with the OpenAI's API to enhance the AI-driven capabilities. So let's take a look at the app-service.ts file. And this is where I've made the workshop be interactive. You are going to be asked to input some parts. If you don't want to input some parts, you can still go to the finished AI ng docs and find the finished code here. It has the same structure. So let's take a look at the app service. So in the app service, first we're getting the OpenAI object. Then first of all, this is an endpoint where a user sends the query to. So this is what the endpoint receives. The endpoint receives the query as a string. So we take the query, and what did we say we do first? We create a query embedding. So part of the task is to create this this code, but yeah, let's take a look at the API reference. So you have your query as a string, and you want to get back the embedding for that query. So if you go to the documentation page, you can see how you can form the actual embedding. And we saw this before as well. This is very small, but if you click the link that I have in here, you can see it. And I'm going to show the response as well. Essentially, you call the OpenAI.embeddings.create. You choose the model, which we're using ADA, as we said. You add the input, which is the input string. And you get back the response. So, OK. Does anyone want to try it out? Or I guess I'll show it. It's OK. Now, create query embedding. So the way you would do it in this case would be, as I said here, you call the create, you add the model, you add the input, which is the query the text, and then you get back the embedding from the data that you get back from the embedding response. And you return the embedding. Now, the next step is to search the documentation. And what we're going to get back from searching the documentation are the paid sections. So this is the part where you are going to use your embedding, and you're going to query database, to Supabase, to get back the responses, the sections that are similar to the embedding of the query. Is this clear? Yes. So let's see the search documentation part. I guess, again, I have left this for you to fill in as an exercise. Yes?
What's the docs URL supposed to be?
What do you?
For docs path.
Oh, good question. The docs path, the n variable docs path is, where is it? Where do I have it? Oh, it's in here. So the docs path is the path to your documentation. So you can add the full path to where your documentation lives. You have to make it up, sure, but I mean, in this case, I have downloaded here the Angular repository, which I think has all the documentation under Angular/AIO. So you would add here like the full path to that. Or you could also do like, I guess, where is it? Yeah, like something like Angular/AIO. Or I would definitely add maybe the full path, like, I don't know, /project /narwhal/ng-conf workshop /Angular/AIO. So that would be the path to your documentation. So I'm so jealous. Okay. So as I said, in Supabase, in our SQL editor, we have this query here. And in this query, we have this match page sections function. So what you're doing here is you're calling a Postgres function from your front end, right? So the way to do that, Supabase says here that, wait, it's not what we want, is it? Yes, here is what we want. The way to call that function is to do await Supabase RPC and the name of the function that you're calling, right? So essentially, let's again see the finished result. Where is it? Sorry. You would go here, you would do the same thing, supabase.rpc, the name of the function you're calling, which is match page sections, and pass the embedding and some of these. What these are is the threshold is the how accurate you want the matching to be. If someone has a better explanation, I will hear it. The match count, how many entries you want it to return, and the content length that you want for your entries to be. So this is how you would call the Postgres function that is here. Is this clear? Yes. Good. Yes. Again, trial and error. I cannot give you a number because it will work differently for your documentation. The same way that we did with the threshold again. Because if we had a stricter threshold, it wouldn't return anything. If you have a loose threshold, it will return the whole documentation, right? So again, it's trial and error here. The same for the match count. The 15, I think, is too long. You could still do like with the 5 top results of the sections you get back, because you don't want to add like super long context for 2 reasons. First, it's going to get lost if it has a lot of context. You're not going to get an accurate answer. And second, it costs more because you would have more tokens. And as we said, tokens are expensive, especially if you're using like the more advanced models. So the next would be to get the context text from the page sections. This is just simple. The only reason we're doing the tokenizer here is that we are considered of how many tokens we end up using. So in here, for this case, we would only use up to 2,500 tokens. Again, this depends on how much money you want to spend And if you don't care about the money, you wouldn't put a token count limit here. So the context text would just be to just trim the string and remove like empty lines or just like breakers in the text so that everything is one. So it's not something super complicated. Now the final part is the create chat messages, which is the most important part of what we're doing. And the most exciting, maybe, is you create a query. In the query, you add the context, and you also add the user's question. So here, I have just created a simple query. And again, with the query, it's trial and error. This is very simple. You will be provided sections of the Angular documentation in Markdown format. Use those to answer my question. Only provide the answer. Start replying with the answer directly. The sections are the context text. The user's question is the query. And again, I'm saying answer as Markdown, including related code snippets if available. So that should pretty much give GPT the required context. However, we can talk about roles here a little bit. You have 3 roles when you're working with GPT. You have the system role. The system role is the first command that GPT takes and sets the general tone of what the conversation is going to be like. If you're using ChatGPT, which I assume you use, you can add your own system prompt in the settings. You can tell it what it should call you. I'm telling it to call me Katerina. What I am, as I said, I'm a 36-year-old woman. I'm a software engineer. I write TypeScript, so that it knows what the whole conversation is going to be like. Then is the role of the user, which is the person who is asking the question. And then is the role of the assistant, which is GPT that's giving you the answers. So in each message, if you're using the chat completions, you can start with a system role message. You don't have to, but you can. And you have to add the user role content, right? So you can create these. And then you get back, and you call this the chat messages array. The reason is because we will be using the chat completions in this workshop. There is also the more new thing from OpenAI is the actual assistant API, but it's still in beta. I have links to a blog post I wrote about it, which also has like a code sample and fully integration thing, but it's still in beta. So this is why I and people who are using OpenAI for assistants, I'm pretty sure they're using the chat completions API as well. So let's take a look at the documentation. The way you would create a chat completion. Okay, let's look at the final thing, I guess. Would be you call the OpenAI.chat.completions create. You choose a model. Here we're using GPT 3.5. We're using the turbo version, and 16K means that it can take up to 16,000 tokens. And this means 16,000 tokens for the whole messages array, right? So usually, if you want to have an actual chat where you ask a question, it gives an answer, you ask a follow-up question, it gives a follow-up answer, etc., this is like a full chat thing, right? So this whole thing can go up to 16K tokens. The temperature, I'm not sure how to explain. Let's read, though, however, what it says. What sampling temperature to use between 0 and 2. Higher values like 0.8 will make the output more random. Lower values will make it more focused and deterministic. Again, we're using 0 here because we want it to be very accurate with our documentation, but depending on your use case, you can be more loose. The stream here, I have set it to false because I haven't implemented a streaming mechanism for you in this example. If you're using React, there are some very nice APIs you can use for, they're called AI Reacts. I think they're from Vercel. And they have implemented this whole streaming thing that is easy for you to do. In Angular, I guess you would have to write it more manually. What streaming is that the model replies like letter by letter, and it looks like someone is actually typing. This, of course, is better for user engagement and user interaction, and it's better than having a spinner to actually see that, ooh, someone is typing. It's the same thing, right? It takes the same time if it's typing to write the whole thing, or if you just waited for the whole thing to come back. But perception-wise, it's better to see typing. Here we'll have it to false, however. And if you want to implement an actual, as I said, chat, where you have a response and another response, et cetera, you also have to implement, you would have to keep messages in store, right? You could use NGRX or just local storage, or I don't know what you would use, like a variable to keep all the messages that go back and forth. And each time you would send back to GPT the whole messages array with the new messages, so that GPT can use all the messages that were before in order to answer your question better and have better context. However, here we're just doing one question, one answer. If you want, you can enhance it, or you can look at how we implemented it at the next, where we do have all this memory. And the response text is the actual content of the message you're going to have. It gives you a number of choices. We're just taking the first choice here. And let's see how that would look. As you see, I've also added types to everything so that if you go home and open it, you can just go in the types and look how they look and what they expect and what they look like. So let's see how this would look. So, wait. AI ng-docs. So for this to work, first you would have to serve the API. And then you would have to serve the chat. And again, as I said, I have embeddings here for the Angular documentation. So if you would go here and ask, I don't know, what are signals? It would have this loading spinner instead of typing. And eventually, it would give an answer. Nothing broke, right? Oh, there is something broken. Why? Oh, no. Nothing works when doing it live, right? It was working before. Oh, no results found. It's weird. Yeah, because I didn't finish the embeddings and it was overwriting. OK, let's do this one more, and I'll ask something else maybe. What is Angular? Of course, error handling is important. We should have seen an error here. Maybe it has an answer of what is Angular. And maybe I should finish the embeddings instead of making it stop. Yeah, it won't give an answer, I guess. Because the embeddings are not... oh, it gave, OK. So yeah, it says what Angular is based on the embeddings that we already have. It couldn't answer about signals because I didn't finish the embeddings. Yeah, so that's pretty much it. I think, I really think this is something that's simple that anyone can do, and I really think it gives value to documentation. And I really think it's not that costly to add. I think in NX we're paying like $100 and something per month, which, given the value that it may give, I don't think is much. So I think this, what? Oh, sorry. OK, maybe it's more than that, but yeah, I do think it's pretty simple, and I do think you can clone my repository and try it out. So make a note of this repository. And if you go on this repository again, as I said, it will, do I have something else here? Wait. Next step. No, the Angular app, okay, the Angular app. Yeah, okay, I had to show the Angular app as well, but it's not important, just an Angular app that makes a query to an endpoint, so it's not really just a query service, hits an endpoint with the HTTP service and gets back a response. So yeah, if you know how to use Angular, it's, yeah. And the ways you can enhance this, as I said, is make it into a chat interface, implement the streaming response, or explore the OpenAI Assistance API. Also, one last thing before I finish. I still have 4 minutes left. If you're using ChatGPT, you can use the AI assist, the ng-AI assistant. You can find it in there. And I have to tweet about this. I have not tweeted about this yet for some reason. The cool thing is that if you're using the ChatGPT Plus, because this is only available for Plus users, you can create your own GPTs, right? So you can go there, you can upload your documentation through the UI. You can just click Create, upload your documentation here as a knowledge base, and it gives you back what we just took in our building, right? Which is just super, super simple. However, what's the advantages of having your own is that the ChatGPT stuff is only available for GPT Plus users, so you would miss the Plus users, or the non-Plus users would miss your feature. And the second, you would have to manually go and update your documentation. Whereas in the NX case, or in your case, if you do it, you can just set up a GitHub Actions that will run every week or every time you change your documentation, right? So that it's always up to date. For us, I think it updates twice a week, every Monday and every Thursday. So, you know, it has the advantages of that. However, if you don't want the advantages of that, you can just go ahead and create your new GPT here. What else? Yeah, I think that's it. And a cat picture, as I promised. This is my cat sleeping, very, very tired. So I guess that is you after a full day of conferencing. So what else do I have to mention? Oh, yeah. And as I said, if you go here to the start, you are going to, it's linking back to the finished version of the code, which you can actually clone and do your own thing at your convenience. So I think that's it. And try out our assistant, please do. OK? And that's it. You can follow me at CyberCity, and you can also follow NX Dev Tools on Twitter as well. And that's it.